All right. So once again, for the sake of recording, good morning, everybody, and then let's get formally started with our um, the content of today. Okay, just a quick recap of what we have seen yesterday or the last session. We just started off with with a very heavy topic about data independence, right? We talked about data independence and we talked about physical data independence and logical data independence. Physical data independence talks about the ability of DBMS to fetch data irrespective of where the data is located. I'm underlining where, okay? That's physical data independence. Logical data independence talks about the ability of DBMS to fetch data irrespective of how the data is stored. When I mean how, in what order, in whatever columns comes first, whatever columns again comes next, whatever is my key field, irrespective of what I store in the DBMS in whatever fashion, my DBMS must be able to fetch the data that I need uniquely. Okay, those are the two broad classifications. With that, we went into file organizations for physical data independence. When we talked about where the data is stored for physical data independence, the data is stored in files. And then we talked about different types of files or file organizations, sequential, serial, sequential, random. And then we talked about different forms within them, their advantages and disadvantages. All right, that's where we stand. We'll go into the logical data independence shortly, probably end of the day today or tomorrow, or the next session. And we slightly touched upon the DBMS architecture, whatever I'm sharing here. All right. I don't know if you guys did have a chance to go read. If you did not, I'm going to request one more time. I want you to go through the textbook, read, and understand. This will be the best time for you to correlate what I'm speaking versus what's on the textbook. If you do it, probably 2-3 weeks later, you will forget what I spoke, and it'll be hard for you to remember the examples that we used and bring it to your brain and memorize or maybe register in your brain um, what I spoke, the concepts I spoke, the examples I gave, along with the concept that's on the textbook. So I'm going to request each of you, please spend some time after I'm done. If I'm spending 1 hour of my time, it should not take you, more than 30 minutes um, for you to go through it. Do you guys still hear me well? And Nagesh said my voice is breaking. I don't know if you can still hear me. There may be some network break, but if you continue to have interference, let me know. So, so the yes is for you can hear me well. It's no more breaking. Okay, cool. Um, okay. So I got a couple of confirmations that it's coming through well. Okay. Okay. So going back, so that's my request. Okay. I want, as soon as I'm done with this session, I'm going to request you to go through the textbook and understand. Okay. We are going through a lot of concepts. That's very important. And the next couple of sessions or 3 sessions, I'm assuming, is going to be a little heavy and more concept oriented, which you need to understand. And this is more important. If you end up to be in a designing field of DBMS, these are some of the things you need to know. You cannot just go start designing unless until you understand the concepts. Okay, and a lot of times, excuse me, um, we have studied concepts, and when we study the concepts, we think that we're not going to apply them. Just, sometimes people say theory is different than practice. It is true, but not always, right? You have to understand the theory to apply it in practical life. So please understand. Okay, with that kind of background, I'm going to get going into the architecture. We talked about 1-tier and 2-tier architecture last session. I'll just quickly touch upon though before I skip on to the third one. So remember the example I talked about, if you can recollect. We talked about a restaurant, example of a restaurant where, excuse me, where you have a restaurant, you have a kitchen, you have a cook, and you have a server who serves the food, and the client who goes into the restaurant, right? So if you remember that example, we talked about client-server technology. Anybody who requests for a service is a client, and anybody who is serving is a server, right? So 1-tier architecture, I said, both the client and the server reside in the same layer. Like I said, the example of the cook who cooks the food in the kitchen consumes the food, right? So that's the example of one-tier architecture. Here, the food is the data, and your cook is your um, the cook is your consumer. Okay, so in this case, both of them stay in the same layer, the kitchen. So it's a one-tier architecture. So same here, your DBMS data and the consumer of the DBMS stay in the same layer. When I mean the consumer here, your consumers are your programmers and your database designers or DBAs. Okay, the way they access the data is basically through a query. They query the database through an SQL. Okay, structured query language. Through that, they query the database and get the data. There is no UI involved. There is no user interface. There is no screen. There's no screen, etc. That's your one-tier architecture. Make sense? In your two-tier architecture, we talked about there's an application program. So far we talked about the way we access the data is through an SQL, but in two-tier architecture, you are writing an application program to fetch the data. Okay, so the application program talks to the DBMS and gets the data. Okay, that's your two-tier architecture. This is where I told an example of you go into a restaurant, you order something, you talk to a server, the server goes into the kitchen, gets the data, whatever you ordered, serves you. Okay, you have no visibility of how the kitchen looks, what exists in the kitchen, right? You only have visibility of the server. So you talk only to the server, he fetches the data. Okay, so this is your two-tier architecture. So here you have an application layer that comes in. The DBMS is accessed by an application program. Okay, this two-tier architecture. I think that's where we stopped last class. So I'm going to go into the three-tier architecture. So I want you to clearly understand this because there are questions in your exams to explain the architecture of DBMS, three-tier architecture, or all the three tiers. I think you have 5 more questions. So you don't need to put everything that is on your textbook. You know, you should always try to write in bulleted forms. I'm sure, you know, you have tips on how to present in the exams. You know, you should have somebody covering that for you. A lot of times we know a lot of things, but are we presenting it properly? That's the key question. You don't need to speak everything that you know about something. Okay, you need to talk key things, write them in terms of bullets. So whoever is looking at it, reading at it, should be able to read precisely. Don't write a whole paragraph like what you're seeing here on the screen. If you have to talk about three-tier architecture, don't write everything that's here. Just write only the bullet points, only the important points. Okay, these are key for you. Don't think if I write this point, I get extra marks. No, the person who's going to look at your answer is just trying to understand if you understood the concept and how you presented it. Always present the key points, underline your key points, highlight your key points so you're not, for example, if I'm looking at your answer sheet, make it easy for me. Look at this way. Make it easy for me to correct your papers. So if I look at your paper, I should only look at your key points and then say, okay, you got your key points, that means you understand. Okay. All right, so three-tier architecture, very important to understand. Here, still continuing the same story of the restaurant. Okay, now what happens is a lot of restaurants now have come with, you walk into the restaurant, there are new ways of ordering. First thing you talk to a computer screen. Okay, you walk into a restaurant, you sit on a table, and then you have a small touchpad or a screen through which you can place your orders. Right? There are restaurants, they even serve automatically. Like I've seen like moving train kind of thing. The food gets served through a moving train. I don't know if you've seen that, if that exists somewhere around where you live. But everything is automated. You don't talk to people. You go put in a request on a screen, and the food gets, the order gets placed, the order gets served. So let's take a similar example here. So you walk into a restaurant, you have a front end screen where you can see the menu. Okay, these days, the menus are like a book, right? A lot of items you don't even understand, you don't even pronounce the name of it. So you place your order through the online screen, and somebody receives your order in the background. Okay, that's usually a server, and then he passes it back to the kitchen, where somebody prepares your food, and then the server picks up the food, but the food is served by the server to your table. Okay, so there are three people involved here. Number one is your user interface through which you order the food, right? I use the term user interface. The user interface, use the term UI, GUI, whatever it is. So you talk to the GUI, you place your order, the order is received. Maybe the server takes the order from the UI, somebody's sitting at the background. Maybe there's one person instead of 10 person. There's one person reading the UI, data from the UI, passes it back. So you have a user interface. What you see here in the picture is a presentation layer. So you are being presented with the information. The presentation is nothing but their menu card or your user interface. Okay, that's actually telling you what are the dishes available, how do they look, what is inside them, what is the ingredients in it, what's the cost, what's the price, things like that. What allergies do they have if they have allergies? That's a presentation layer. So you have, if you see the picture on the left hand side, you know, you have a user interface, okay, and the user interface then passes the information back to the server. Now, if you see the term here, the application server. So the server picks up your order that you place on your user interface. Usually here, there is an application program involved. What it means is all your user interface that you see on the screen are designed through, some of the application programs, maybe like very simple form, maybe let's say HTML or a PHP script or, JavaScript, or maybe, yeah, some of your scripting languages, some of the user interface designs. Okay, so you are going to design what should be in the first line, what should be in the second line. Is this a fixed field? Is it a variable field? Can this, is this a constant? Can it take inputs? So you're designing the screen, right? You're designing the user interface. That is done by your application program, right? Or your Java or your scripting language. So that designing is done by the application program. So the moment you place your order on the front end screen, the communication starts from your presentation layer to your application program or your application layer. Make sense? Now, what does the application program do? Based on the conditions, for example, there are always things written like on click of a button. Okay, you may have written like on click, perform this, set property or get property, things like that. So on click of this button, I wanted to go talk to the DBMS and fetch some data for me. So that is what it means. The application program or your server is talking to your cook to say from the kitchen, can you fetch me this? Somebody needs a plate of idli, let's say. So can you fetch that data from your database? So that's what exactly happens between your application program and your DBMS. So your application program will have an embedded SQL in it. I used the term embedded SQL in my last session. Embedded SQL meaning there is an SQL embedded within your application program. Okay. So you receive the input, create your SQL, embedded SQL, feed all the necessary information, go into your database, get the data that you need, and then you come back the same way. The reason why you see two-way arrow marks is because it goes one way, comes back the other way. So it talks to each other both forward and backward. Okay, so the application program talks to your DBMS in terms of a query. Remember that it cannot talk on its own. There has to be a query. I'll talk more about CORD's rule later. So there has to be an SQL that talks to the DBMS and then says, can you select this data from the DBMS? So the DBMS gives the data, the application program carries the data, and the application program puts it on the user interface or the UI screen. This is exactly what happens in every application of DBMS. Banking, ATMs. You have ATM front-end screens. The ATM screen talks to an application program. The application program talks to the tables or the DBMS behind it. Okay. You talk about telecom industry, same thing. Okay. Any front-end screen that you see internally talks to an application program, which internally talks to a DBMS. Make sense? Clear? I want you to understand with an example so it's easier. So quickly, some of the items that you should be knowing here. What resides in the database layer is basically only the database resides. Okay. What resides in the application layer, your application program resides in the application layer. Okay. You have to understand this point. Users are not aware of the existence of a database beyond application. A lot of times when people use ATMs, they don't even know what is happening. They go to the ATM, like I said the other day, for them, excuse me, for them, it's basically if you click the button, it looks like we might get disconnected, guys. If we get disconnected, I have shared another link, join back on the other link, okay, if in case we get disconnected. So application layer, the users are not aware. Like you are using an ATM, you are not aware there is an application program. The user does not know there is a Java program running or anything, and it's talking to your database. No. Okay. So continuing where we were, application tier. So application tier, like I said, the application program resides, and the end user has no clue that who is he talking to. All he knows is there is a presentation layer. Okay. And um, when we talk about application layer, you got to understand he is the mediator, if I can use the term, between the client and the server, or the client and the DBMS. Okay, so the application layer sitting in the middle. For example, the application layer is pretty much compared to a server in the restaurant. The server can talk to me, who's the client, who's consuming the food, versus to the cook who's producing the food, right? So he sits in between, who can talk to. He's the only guy who has access to all three layers. So the application tier has access to the presentation layer because he's the one who decides how the application user interface looks, and he is a guy who talks to the database. So you should mention this point if you're writing your exams. The application tier talks to both presentation layer and the database layer. Okay, but whereas the end user does not know anything beyond um, yes, the end user does not know anything beyond there is an application program. Okay. Now, coming into the final layer, the user interface. The user interface, or the user, has no clue of, like I explained, when you go to an ATM, the user has no clue of what's happening in the kitchen. um, I think I just want to use this example. If you go into the restaurants, there is always a board that says right outside the kitchen, no admission. I don't know for what reason, but they usually, almost all restaurants in every place I've seen, no admission outside the restaurant. Okay, I don't know why. So same like that, the user is not allowed to have access into the DBMS layer. Okay, the user has no clue of what's happening inside the kitchen. Same way, what's happening behind the application. Okay, the user knows only that there is a server involved. So the user has visibility only to the application layer. Okay, he talks to the UI, and then he knows there is an application program involved. Okay, but other than that, he does not have any other knowledge about DBMS or how it works, how the data is stored. Okay, there's one other additional item, different views. I just want to use this term, but I will be talking about it as we go down. All views are generated by applications. What is mean by a view? Like I used this term in one of my previous days. A view is nothing but a small table, a subset of a table. If you have a table with 1,000 columns and 1,000 rows, and if you select only a 10 column and a 10 row based on some condition, I don't want all 1,000 columns. I only want to see only the 10 columns and only for 10 users. So you are limiting the whole table to a 10 by 10. That's called a view. View is nothing but a subset of a table, if I can use the term. If you have a question in exams asking what is a view is a smaller or a subset of a table. Okay. I usually say this, a view is nothing but a window through which you are looking at the external world. There are so many things in the external world. Okay, if you look through a small window or through a small, a small lens or something, you will be able to see only what it could, the window could show you, right? So that's exactly what a window is. I mean, sorry, a view is, sorry. So anything that you could see through A view is nothing but a subset of a table. Okay, sometimes it could be the whole table, but generally it's created um, to to extract a subset of data. Why do we use it? Because a lot of times I might have a huge database, but a lot of data is not frequently used. Okay, if I go into a huge, let's say, college database, I store so much information, but the data that I frequently use could be student number, name, maybe date of birth, and their address. Not every single day I would want to know certain traits. What's his hobbies, what's his interest, what's his father's name, what's certain features of the student. I'm not interested. Even at the banking field, a lot of times, we store so much information in the banking database, right? Your Aadhaar card number, your PAN number, etc., etc. But I don't access the data every day. So when I go access the database for a specific item, let's say for example, I am going to fetch your date of birth, I'm going to access the whole table. The whole table loads into your memory, and then you're going to say, okay, give me only this particular column, this only particular record, right? So you're going to load all the data, and from there you're going to select something. Instead, what I do, based on the frequency of my access, I'm going to access, let's say, a lot of times frequently I'm going to access the student number or the customer number, customer name, his date of birth, his bank balance, his address. Let's say I will create a small view containing only these columns, right? So what happens next time when I will say get the data not from the table but from the view. Make sense? So thereby I'm not loading all the data, I'm loading only a limited data. I can also give a condition saying get me all the only the 5 columns of my customers who come from Mysore. So I create a view to say, give me the name, number, address, phone number of all the customers that live in, let's say, Vijayanagar, Mysore. So tomorrow, if I'm going to access the data comes from a smaller view rather than a bigger table. Make sense? So far, so good. Any questions? Understanding the view, or if some of these things, if you feel are very relevant to you, you're well versed, I would like to skip them and keep going, because I come into this session assuming you guys don't know certain things, but things have changed. You guys know more than what I know. I think you guys are in a different world these days, right? You guys know more than what I know. So if you think that these are certain things we know, please keep going. Then I would skip. I don't want two things. I don't want to waste our time. Neither you're not mine. Number two, I don't want to be boring. If I keep talking something that you know very well, I'm going to lose your interest. Okay. There are two things that you lose interest. If I talk something that you know very much, and if I talk something that is 1,000 feet above that you can understand and assume. Okay. So if you think this is pretty clear, we don't want to listen, we can keep going. All right. So that marks the end of your architecture. Okay. We talked about three different tiers of architecture. From my understanding of going through your question papers, this is a very important topic, and I want you to present it nicely when you go into your exams. Okay. Now moving on, database modeling. Okay, let me quickly check if I have anything else in mind to cover in my notes. Okay, now we can keep going with database modeling. Okay. If it's too dry, just take a sip of water. That's the best we can do. I know it's tough, but let's. If you want me to stop, really let me know. Just plan to go for another 30 minutes. Now, database modeling. What is database modeling? Database modeling is nothing but how the data is represented. Okay. Logically, for me to look at, for example, I talked about the blueprint of a building. When somebody is going to start building a house, they create a blueprint to say, this is how the house is going to look. They're presented in different ways. They give you, front view, top view, they call it elevation, plan, etc., etc. The same building, how it looks from different ways, So you can represent the data same way in different models. That's what is called data modeling. Basically, if you want to use the term, there are questions. What is data model? You can simply say data model is nothing but it's an abstract model to represent the data. How the data is how the data is represented and stored, and used. Okay, it's basically the structure of data. I'm not going to go into all these theory. I'm assuming I'm sharing my screen. If not, let me know. I'm not going to go into all these theory. These are certain things that you can read and understand yourself. It's not like something I really need to make you understand. These are basic theories. What I'm interested here is, I know somebody, I think it was Gahan, who asked me the very first day, what are the different types of database modeling? Are there different database DBMS that exist? Yes. So this is where the answer comes. There are not only three, there are many database modeling, how you represent your data, but primarily we talk about these three in a lot of textbooks. And the frequently used one is the last one, relational modeling. Okay, but for the sake of your textbook, I'm gonna quickly touch on what's hierarchical model and what is network model. Okay, so let's talk about it a little bit and then go. But before I go into that, I just want to introduce types of relationship. When I mean types of relationship, it's DBMS relationship, not your personal relationship like friendship, teacher. No, it's your DBMS relational terms. Okay, so the three different terms that I want to introduce. One is one-to-one relationship. What is a one-to-one relationship? So I'm going to take you back slowly to certain things. We talked about an entity. Okay, when we talked about the terminologies of DBMS, I talked about entity. So an entity is nothing but a representation of a table, right? So there are two entities. For example, let's talk about the example of a college. Okay, a college has departments, and the departments offer various courses, right? For example, you are near college, your college can offer various different courses, and the department can also have various professors enrolled in the college or the university or the department. And same way, the college can offer, or the course can offer, I'm sorry, the department can offer various courses like DBMS course, like networking, okay, mathematics, whatever, okay, they can offer various courses. And students enroll in these courses. So each of these is an entity here. Student is an entity. College is an entity. Course is an entity. Department, professor, each of them are entities. In simple terms, excuse me, anything that the way that I would say is if it's a noun and if it has some attributes associated to it, it becomes an entity. When I mean, if you remember what is an attribute, it's nothing but the properties or features of an entity. For example, student. Excuse me, guys. Give me a quick second. Okay. So these are the attributes. For example, if you take student, the student will have name, address, phone number, date of birth, etc. So those are the attributes, and student is the entity. If I can talk in different terminology, student is the table, and all his attributes are the columns of the table. Same way, course number, course name, the credentials or the CV points for the credit points for the course, things like that. Make sense? Professor. If you take professor is an entity and he has attributes like professor number, professor ID, the courses that he handles, and the details of the professor, his name and other things. Okay. So now let's talk about one-to-one and versus one-to-many. One-to-one is basically meaning that two entities are related in a one-to-one relationship, meaning I'm trying to think an example. where an employee can have only one spouse, or a person can have only a spouse. For example, if you go into the college databases or or office databases, we have an employee, we have a spouse. So technically speaking, an employee can have one spouse legally. Okay, I'm not talking anything outside of the legality. So legally, an employee can have one spouse, and same way, a spouse can have can belong to only one employee, right? So this is basically meaning a one-to-one relationship, meaning there cannot be multiple instances. Okay, whereas if you talk about one-to-many, an employee versus a manager, let's say an employee can have only one manager, whereas a manager can manage many employees. Yes, so this is what we mean one-to-many or many-to-one relationship. It is one-to-many if I look from the employee side. I'm sorry, if I see from the manager side. One manager can have many employees with them, so it's a one-to-many relationship. And the other way around, an employee can have only one manager, right? So did I say it right? Yes. So one-to-many or many-to-one is basically one instance is associated to multiple instances. A manager associated to multiple employees. Okay, and many-to-many relationship is, for example, let's take the example of a course versus a department, or a student to a course. Okay, a student can enroll in multiple courses. Yes, I can enroll in DBMS, I can enroll in uh, support systems, decision support systems, artificial intelligence, whatnot, robotics, whatnot. So a student can enroll in multiple subjects or courses, and same way a course can have multiple students. This is many-to-many relationship. Make sense? So I want you to understand this before we go talk about these three different models. So basically, I introduced three different relationships: one-to-one, one-to-many, and many-to-many. Okay. So let's now jump into the different hierarchical model. Again, there may be questions asking, can you explain the different types of data models? What are the different data models? What is the difference between hierarchy and network model? Or, what is a relational model? Different questions. So these are the three models that we're going to talk about: hierarchical, network, and relational model. Hierarchical basically means there is going to be an hierarchy. Okay, what is an hierarchy? There is going to be a parent-child relationship. Every scenario is going to be represented in terms of parent-child. Okay, let's go into here, an example here. So we have the department table, and then we have the course, we have the student, we have the professors. Yes. So now all of these, like for example, the course belongs to the department. The student belongs to the department. The professor belongs to the department. So here, everything is anchored to the department. So the department acts as the parent table, and these are all child tables. So in other words, the parent table is called the parent node, and rest of them are called the child nodes. So hierarchical model represents data in terms of an hierarchy or in terms of a parent-child relationship. What is an hierarchy? We use this term hierarchy. We say, what's your family hierarchy? What's your family hierarchy mean? Who is the great grandfather? Who's the grandfather? Who's the father and child? Okay, it goes down like that. And in your office setup, you ask what's the hierarchy meaning? Who is your immediate boss and who does your boss report to, and things like that. That goes all the way up like an organization chart. Until it goes up to the CEO of the organization, right? So that's what is an hierarchy. So if there is a question of what is hierarchy model, I would say in a hierarchical model, the data is represented in terms of nodes. We use the term node. If I can go back, if you show this is called the data is represented in terms of node, and the root node or parent node is the starting point to which all the child nodes or other data is anchored to. Okay. So now, with that being said, you have to understand certain things. Now, there is always only one parent node, okay? The parent node in this case does not have any other parent. So the starting point for your data is here. Now, this is where the data gets represented to start with. Okay, and now these are called child nodes. There can be one parent node and multiple child nodes. A parent node can have multiple child nodes. What it means is a one-to-many relationship. So a department can have many courses, department can have many students, department can have multiple professors, okay? Or a department can have only one course it's offering. A department may have only one student, it doesn't really exist, but I'm just saying. Our department may have just started as only one professor. So hierarchical model will represent data that are possible for a one-to-one and one-to-many relationship. It does not allow you to have many-to-many relationship. If I can rename in a different terminology, a parent can have multiple child, legally agreed, allowed. A child legally can have only one parent, biologically can have only one parent, yes, but a child cannot have multiple parents, not allowed. Same way, multiple children cannot have multiple parents, right? So when there is a necessity to represent many-to-many relationship, hierarchical model does not help. Okay, makes sense? So what is the advantage here? The advantage is this, so that will be our, I just want you to understand one advantage if you have tried in your exams. So the advantage for hierarchical model is the data is clearly represented in a parent-child relationship. The data is predictable. What is the meaning of the term predictable? Why do they use the term predictable? It is because, and usually we say, right, I mean, when somebody in olden days, when they ask you who are you, they usually ask who's your father, whose son are you? That's how they used to ask. I think even if you go into villages these days, the first thing when somebody sees you new, they want to understand who you are. The first question they might be asking is, whose family do you come from? Who's your father? What's your father's name, right? So with that, they will identify who you are. So that's exactly what's the advantage here. So it is predictable. I can predict who you are based on the parent node, based on the parent node. Make sense? So that's the advantage here. Now, disadvantage is that it does not allow for many-to-many relationship. Okay, that's one. And the other advantage is that things are hard coded, meaning course is the child of parent. Tomorrow, if course thinks, I want to go into a different department, that is not allowed. That's not possible to change. Meaning, it's more like a child saying, I want to change my parent, right? That's not allowed. You cannot do that, unfortunately, right? So that's the disadvantage of hierarchical model. So your child node is hard-coded or linked into the parent node, and the child node does not have a flexibility to change the link to its parent node. If one of the link breaks, if the parent-child relationship is broken for some reason, it's hard to track the data. For example, if you look here, we have the root node, we have child level 1, child level 2, meaning this is like, grandfather, father, and a child level relationship. If for some reason, if this level 1 link is broken, there is no way I can reach to that level 2. The link is broken. So this is another disadvantage. Make sense? So there is no chance of many-to-many relationship. There is no way the child node can change the parent node. If one of the link is broken, it is impossible to track down to the lowest level of data. All right, with that being said, I'm going to go into the next model, the network model. I don't want to spend too much time again here because, like I said, these are not very much used these days. These days, it's more the relational model. So I would like to spend more of my time in relational model. So I'm going to continue with the network model quickly. So network model, it's pretty much the same thing. But here the one additional item is it allows for many-to-many relationship. So here also the data is represented in terms of nodes. You have a parent node, you have child nodes. A parent node can have multiple child nodes. A parent node can have one child node possible, but note, a child node can have multiple parent nodes. It's more like saying a child can have many parents. That's not biologically allowed, right? So that's looked at as an advantage as well as a drawback. The drawback here is it's very confusing. So if you look at here, this is how the data is represented. The department has a student enrolled in it. The department has a course that it offers. Department has professors, and then now look at the link. The professor is linked to a student because I can very well say this student attends the course that this professor is handling. Okay, so the student enrolls in this course. Now the student and the course are directly linked. If you look at the hierarchical model, okay, the student is enrolled in a course and the course is offered by the department. So you have to follow that link. Okay, here, no, I can directly link the student and the course. So the advantage here is it allows for many to many relationship to be represented. Okay, but unfortunately, it is very cumbersome to represent. It's confusing. Look at this small thing. You have so many links and short circuits here. Assume you're defining a whole big database, DBMS, for a banking application. This is going to be very difficult. Okay, it's very short-circuited, very convoluted, very difficult to represent and maintain. Okay, makes sense. Um, there's basically no restrictions on. That's what it says. There are no restrictions on the number of relationships. Anybody can be related to anybody else, which legally not allowed. Um, but that's how it is network model all about. We're not going to go into the details of it. Our interest is more about introducing you to relational model. That's my interest here. Then you may have a question, if the interest is not of hierarchical network, why are we talking about it? It's more like this, anything you want to introduce, before you do that, you talk about the disadvantages of something, right? Like for example, before I started talking about DBMS, I talked about file system. I talked about file system, how the data is stored in the files, and then I slowly talked about the problems of the file system. Then I said, it's very difficult to use file systems. So now let's go into DBMS. So basically we present with a problem and then we come into the advantages and present the updated model. So that's what is the relational model. This is our area of interest. So this is all about RDBMS. We have been talking about DBMS. DBMS stands for Database Management System. Hierarchical model is a DBMS. Network model is a DBMS. Relational model is a DBMS. Now, relational DBMS is called RDBMS. You will hear this term between a lot of times people use DBMS or RDBMS interchangeably. The difference between this is this. DBMS has multiple models. Relational model is called relational DBMS. Okay. Now I'm going to ask a question to all of you. What is a relation? I'm assuming I used this term in one of my days before. What is in DBMS terminology? What is a relation? What is a relation? Let's see, somebody has got something. Connection. So relationship is a connection. Yes, any other? From what I've said before, if you remember, go back a little bit when we talked about the terminologies. A relation is nothing but a table. Okay, in DBMS terms, a table is also called an entity or a relation. Okay, why is it called a relational model? Because we're going to represent the data in relational model in terms of rows and columns. So if somebody has a question about what is a relational model, in simple definition is this: a relational model is nothing but it's a type of DBMS or modeling of DBMS that uses relational way of representing data. Relational means representing data in terms of rows and columns. So you represent your data not through parent node, child node. but through rows and columns. You're representing your data in terms of rows and columns. Make sense? So if you quickly look at, if I can go back, um, share my screen here. Where is the share of my screen? Go back to the table here. Now we have been looking at this, right? So here, this is the table that we used. So now if you look at the first record, okay, for a change, let's go to the last record. So let's look at the last record. I'm storing details of Krishna here. His student number, yes, whatever student number I have assigned, student name, gender, date of birth, and average marks and grade. Okay. Now here, this particular record or a relation is nothing but data, right? Each cell, I use the term cell here. Each cell stores data. The last record, the first cell of the last record stores student number. The second cell of the last record stores the name, gender. The next column stores gender, date of birth, etc. But what are these? These are all details related to Krishna. Yes, I use the term related. Now, all these data are related to Krishna, or in other words, every record contains the related information of an instance of an entity. Too many terms. The whole table is called entity. Each record is called an instance of an entity. Okay. So now the last record is an instance of an entity. One instance of a student. Student is the entity. Krishna is one instance of student. Okay. Himani is another instance of student. Sanjana is another instance of a student. You'll study this in your OOPS concepts, right? Instance, a class, an object, and an instance of an object. So each record is an instance of the object. So a record stores related information, related data of one single instance of an entity. Did I make it clear? So if you understand, you should be able to write down your own words. Okay. Now, because it contains all the related data, it's called relational model in simple terms. Okay. A relational model stores data in terms of rows and columns. Every data is stored in cells, and it's called relational because every record stores the related data of one instance of an entity. Make sense? Any questions before I jump into the next topic? I'll just take another 10 minutes and we'll go. Okay, so that's the introduction of RDBMS, okay, relational DBMS. Most of the things that we have gone through, the architecture, the evolution, everything remains the same, but just the data representation is in terms of relational model. Okay, now I'm going to talk a little bit about some theory. I would want you guys to go through this theory, but I will just quickly explain what is each of it. Cord's rule. Who is Cord? He's called the father of DBMS, Boyce Cord. His name is Boyce Cord. E.F. Cord. Now he's considered to be the father of DBMS. So he's the one who defined a lot of rules for RDBMS. Okay, for relational model, he introduced certain rules for the tables to be in relational model. Let's quickly look at what are those 13 rules. There are 13 rules starting from 0 to 12. So it's called Cord's 12 rules or 13 rules. It starts from 0 to 12. Okay. Number 0. Can I continue, guys? And I don't know. I know some of you dropped off. If you guys have other sessions, I will stop. Can somebody confirm I can still keep going? Because I don't want you guys to hold you here. Is there any other session that you guys have that you have to go? Okay, perfect. So I got a couple of confirmation to continue. Okay. So quickly, Cord's rule. Again, this has been another question I saw in your question papers. Can you define or can you mention some of the Cord's rules? Okay. So from a theory point of view, you need to understand this, but I'll try to make it easy for you to remember. Okay. Number 1, the rule states that for a system to qualify as an RDBMS, it must be able to manage through relational capabilities. So what it means is anything that you want to represent, I must be able to represent the data in relational capabilities. Relational capabilities meaning in terms of a record. Okay, you must be able to represent the data as a record. If you don't think you can put this as one record, then it cannot qualify for a DBMS. So second rule, everything must be stored in a cell. Okay, every data. For example, we saw in my other, this example here. This is one cell. The data is stored in one cell. The name is stored in one cell. Okay, so every data must be possible to share in a cell. Okay, that's your second rule. Third one, every cell must be accessible. If I give you the primary key, if I give you the name of the table, if you see here, I must be able to point to a specific cell. For example, I stored the date of birth of Krishna in one cell, which is basically, let's say, the 10th row and the third column, right? So if I tell you the table name, which is the student table, plus if I say his student number as 12, which is the primary key, let's say, and number 3, column name. For example, DOB is the column name. If I give you these 3 things, you should be able to go to a specific cell and get me that information. If we cannot do that, then you cannot go into a DBMS mode. So that system cannot use RDBMS, or you cannot represent the data in RDBMS. Okay. So when is this all evaluated? Basically when you start designing your DBMS. For example, like I said, let's assume you are going to start a new institution, and then you want to store all the details in a DBMS. So while you start doing this, you should first evaluate all my information. Is it possible to represent in a table in one record? Can I store the data in one record? Can I put each information in Excel? Possible? Only then you should go into the relational DBMS. If you think it's not possible, you should not go for it. Okay, then we talk about a null statement, systematic treatment of null. What is a null? Anybody has any clue what is a null? This is a very frequent term that you will work with in DBMS. What is a null? Null is basically an absence of data. So we say nothing, yes, but in DBMS, I always try to use this word absence of data. Okay, see, what are we storing in each cell? We are storing data. Yes, the whole record is an information, but each cell contains a data. Now, null is nothing but absence of data in a particular column or a cell. Put it that way. Sometimes people say it's spaces, it's nothing, it's zero. Yes, but if I would say null is nothing but absence of data, meaning there is no data present in that column. Makes it easy? Okay. Now, primary key cannot be null. Remember that. Primary key. I cannot just say, go get me the data for that null column, for that null record. No. I have to identify each one of you with a primary key. So the primary key cannot be null, and any expression on null must be null. So this is more like anything on infinity is infinity. You multiply something with infinity, his answer is infinity. Infinity by something is infinity. Infinity plus something is infinity. So same way, any expression on null will give you an answer of null. Okay, we'll talk more when we go into SQL. Next, active online catalog. Online catalog basically means a metadata. Your catalog is basically, it stores some information about your data. Like for example, we talked about indexing, right? There is an index. When we talked about the random access method, we talked about indexing. I stored the name or the primary key and where the data is stored. So that's a metadata. Metadata is nothing but I'm storing some information about my own data. Data about data is called metadata. Okay. I think we're gonna run out of time, and I'm gonna stop here to take any questions for a minute. It looks like it's gonna stop. The recording is gonna stop. So I will pause here. We'll continue more on Quadzul in the next session. But quickly, I'll stop here for a second. If you have any questions, anything that you want to bring up, feel free to do that. I'll be here for another minute. If you want to take off mute, talk, please go ahead. Anything that you have, any concerns outside of the subject, if you want to speak, say something, comments, feedback, reviews, anything is open. All right, if there is nothing, I'm not hearing anything from anybody.